All right, Mr. Ahmed here for the start of Chapter 2. This will be Lesson 2.1. And in Chapter 2, our main goal is going to be solving linear inequalities. So instead of an equal sign, we'll be working with less thans, greater thans, less than or equal to's, greater than or equal to's. Now, fortunately, this will be a nice little review of solving equations as well because the process is very, very similar. So in 2.1, we're going to work on writing and graphing inequalities. And that leads us to 2.1 and 2.2 notes. And so these kind of go together. We're going to mix together solving one-step and two-step ones all at the same time. And our essential question is, how do write and solve inequalities? We will also graph them. Now, in this process, a couple different things. Instead of an equal sign, we're going to see some signs that look like this. You may have heard this referred to Mr. Pac-Man, and he eats the bigger one. In this case, we're going to really look at reading it from left to right. So if I look at this sign from left to right, it kind of means that the left side is smaller than the right side, so this sign means less than. And if I look here, the bar underneath means less than or equal to. All right, and if I read from left to right again, this time Pac-Man's eating over here, so this one would mean the left is greater than the right. And we add the bar, so greater than or equal to. So the bar means it could also be equal. When we graph on the number line, if the sign is just less than or greater than, we use an open circle, so something like this. And when it's or equal to, that solution is also included, so we will use a closed circle, so it will be filled in. Because that is part of the solution. This indicates that it is not part of the solution. So first we're going to write each sentence as an inequality. And it says a number x plus 8 is greater than or equal to, so greater than or equal to sign, 12. And we have written the inequality, our very first one. All right, next one says 4 is fewer than twice a number. So 4 is fewer. Would that be less than or greater than? Fewer to me means smaller, so 4 is less than twice a number. So twice means 2 times a number n. I'm taking n, could have used x, could have used t, anything, does not matter. All right, solutions of an inequality are values that make the inequality true. So tell whether -2 is a solution of the inequality. For me to tell if it's a solution, I need to plug it in and check and see if it's true. So when I plug it in, make sure you put parentheses around the variable. Parentheses are right here with our x, so we would have 2 parentheses. We're putting in -2, and that needs to be less than -9. So let's see if that is true. 2 times -2 is -4. Is -4 less than -9? I would say it is not less than -9. -9 is smaller. So this is not a solution. Our next example, again, put parentheses around the variable when you substitute something in. So -2 plus 5 greater than or equal to 3. Notice I'm reading from left to right to get greater than or equal to. -2 plus 5 is 3. Greater than or equal to 3. Is 3 greater than 3? No. But is 3 equal to 3? Yes. So this is true. If the bar were not there, if it just said 3 greater than 3, this would not be true. But since the or equal to is included, it is a solution. Now what's going to happen is we're going to do these problems today where we check and see if it's a solution. And then about, 4 days from now, after we've solved a million of these are going to become like hieroglyphics and we're all going to forget. So just keep in mind, if you're checking to see if it's a solution, all you got to do is plug it in. All right, now we're going to graph some inequalities. Now the graph is a visual representation of all these solutions. So we are going to graph all the solutions for y is less than or equal to 7. Now, when you make these graphs, you don't need to be super detailed. I'll show you that here in the future. But we want to see where 0 is. So I'm going to put 0 here. 1, 2, 3, 4, 5, 6, 7. This would be negative 1. Now, as we said on the very front page, when we graph, open circle if it's just less than or equal to, closed circle less than or equal to, greater than or equal to. So we have to determine, is this an or equal to problem? And in this case, yes, indeed it is. So at 7, I'm going to put in a closed circle. Now we need to shade the direction where all the solutions are true. Now, when I look at this, is 6 less than 7? Yes. Is 0 less than 7? Yes. So our solutions are all to the left because these are all the numbers that are smaller than 7. And I have an arrow indicated here because it could keep on going because negative 1 million would also be a solution. And then I need to make this fairly dark to indicate where it's going. And we have graphed it. All right, now the next one's backwards, okay? It says 3 is greater than x. It's a lot easier to read these if x comes first, so I'm going to rewrite it and say x. Now, what was getting eaten? The 3 or the x? 3 was, so it still needs to be. So this really means x is less than 3. So again, putting up my 0, 1, 2, 3, negative 1, negative 2, that's close enough. Open circle or closed? No or equal to, so it is an open circle at 3. And it's less than. If the variable is less than, we shade to the left. If the variable is greater than, we shade to the right. So in this case, the variable is less than, we are shading to the left. All the numbers smaller are the solutions, and we have visually graphed it. Okay? So when we graph these, I'll keep repeating that. Is the variable less than? Is the variable greater than? If the variable is less than, we shade to the right. I'm going to write this down over here. Variable less than, shade left. Variable greater than, shade right. Okay, so that's going to be the strategy. All right, now when we have to solve and graph, first we have to isolate the variable just like we did when we were solving equations. All right, so in this case we have x minus 8. Our line is here. Left side, isolate the x. We have to move the negative 8. In order to move the negative 8, inverse operation is to add 8 to both sides, and x is less than, sign does not change. 15 plus 8 is 23. Now 23 is a pretty big number, all right? I'm not going to ask that you get this super detailed number line up to get to 23. Just put a 0 somewhere so I know where 0 is, and then we'll say we're at 23 over here because it's bigger than 0. No or equal to. Sorry. Just put a 0 up, then go over some to the right for a positive 23. You don't need to count it out specifically, all right? That's not necessary for us. And now when I look at the inequality, there's no or equal to, so it is an open circle at 23, and x is less than. Variable's less than, so less than we shade to the left. So we're going to shade this direction, put my arrow up because it keeps going, and we have graphed the solution. Next one, y plus 2. Isolate the y, have to subtract 2. Negative 3 minus 2 is negative 5, greater than or equal to y. Now notice the y is not coming first, so I'm going to flip it around, put y first. Negative 5 here, what's getting eaten is the negative 5 is getting eaten. All right, now graphing our solution. Looks like I forgot a number line, so I got to make one. Just draw up a line. Doesn't need to be real detailed. Okay, put up a 0. Negative 5. That's all the more I need. Where's 0? Where's negative 5? And at this case, it is or equal to, so a closed circle at negative 5. And y is less than, so we are shading to the left. Arrow needs to be there. Make it nice and dark so we can see which way it's going. we shaded to the left. All right, the U tries. Pause the video, give these ones a shot, then turn it back on to see if you got them right. All right, hopefully you had a good successful time solving these. First one, in order to solve, we're going to subtract 7. X is greater than 5 minus 7 is negative 2. That is our solution. Put 0 up, negative 2 on this one. That's not too far away, so I'll actually count it. 1, 2, this way. All right, at negative 2, open circle because it's not or equal to. And x is greater than, so we are shading to the right. The variable was greater than. Include my arrow. Got it. All right, last one. Isolate the x, add 4 to both sides. Negative 2 plus 4 is 2, less than or equal to x. Put the x first, 2 second. X is being eaten, so x is greater than or equal to 2. Put up 0, 1, 2, close circle because it was or equal to. And x is greater than, so we are shading to the right. So all the numbers bigger than 2 make it true. And that is all we have for today. Have a good one.